So far, we have learned how to add, subtract, multiply, and divide rational expressions. In this video, we are going to learn how to solve rational equations. Now remember, when I say rational, what I mean is fractions. So we are going to learn how to solve equations involving fractions. Let's start with something very simple. If I tell you that 3/5 equals x over 5, and I say, hey, what does x equal? Well, you can just look at the problem and realize that x has to equal 3. Because if these two equations are equal and you have a 5 on the bottom of each side, then obviously the tops must be equal as well. So the x has to equal 3. So what makes these problems much simpler is if you have a common denominator. So just like when we were adding and subtracting, that common denominator is going to be very, very important. So let's try one that's a little bit more challenging. 1 over x minus 2 equals x plus 5 over x plus 14. Now, before I start solving it all, I do want to recognize here what x cannot equal. Remember, it's impossible to divide by 0. So if this is x minus 2, no matter what, I cannot get x equals 2 as an answer. Because if you plug in 2, 2 minus 2 is 0, and you cannot divide by 0. Likewise, if I look at the denominator over here, x plus 14, I know that no matter what, x can never equal negative 14. Because if you plug in negative 14 plus 14 is 0, and you cannot divide by 0. So in that case, let's start by getting a common denominator. So on the left-hand side, we need an x plus 14, so I'm going to multiply whatever I do on the bottom. Got to do the same thing to the top, so we're going to do x plus 14 over x plus 14. Then on the right-hand side, I need an x minus 2. So I'm going to multiply x minus 2 on the bottom, and whatever you do to the bottom, you have to do to the top. Now the left side has an x plus 14 and an x minus 2 on the bottom, and the right side also has an x plus 14 and an x minus 2. So we're going to bring this stuff down. On the left-hand side, we're doing 1 times x is 1x, and 1 times 14 is 14. On the bottom, we've got that common denominator now. We've got x plus 14 times x minus 2. On the right-hand side, oh, there's a lot to multiply here. We've got to do x times x is x squared. X times negative 2 is negative 2x. See, 5 times x is 5x, and 5 times negative 2 is negative 10. And of course, on the bottom, we have that common denominator. Now we've got x plus 14 times x minus 2. Now, we've got a common denominator on both sides, and if the bottoms are equal, then that means the tops have to be equal as well. So really, I'm just going to take this equation on top, and I'm going to go through and I'm going to solve for x. So let me just jot that down here. We've got x plus 14 equals x squared. Let me go ahead and combine these two right here. X squared plus 3x minus 10. Now this equation is a little bit different than the other one. This is a quadratic equation because it has x squared. So remember, with x squared, you're going to move everything to one side because you want to set it equal to 0. And then you could either factor or use the quadratic formula depending on the setup of the problem. So I'm going to move everything over to one side. So this x, I'm going to subtract x and move it over here with the other x's. And the plus 14, I am going to subtract 14 and move it over here with that negative 10. That leaves nothing left over here. So I've got 0 equals x squared plus 2x minus 24. Now it looks like I can factor this one, so that makes things a little bit easier. Obviously, factoring here, I would need an x times x to get that x squared. And then I need to know what multiplies to negative 24 and adds up to 2. That would be a positive 6 and a negative 4. So when you get here, remember that this is the zero product property here. So I'm going to take each one of these factors and I'm going to set it equal to 0. So here I would get negative 6 for my solution. And on the other one, I'm going to take the other factor, x minus 4 equal to 0. And I end up with x equals 4. Both of these solutions are valid. Remember, these are the only two answers that would not have been valid. So these answers are good to go. All right, things get a little bit more complicated here. I've got a lot going on. And remember, the whole idea is we want to get a common denominator. So right now I've got 3 different denominators. It would be helpful though if I could factor this middle one and kind of look at what I've got. So what I've got x times x, and then what multiplies to 15 and adds up to 8 would be x plus 3 and x plus 5. Well, that should look familiar because we've got x plus 5 over on the left-hand side. We've got an x plus 3 over on the right-hand side. So there's not too much that's different in our denominators here. Now, before I move on, I do want to make a note over here that no matter what I get for my final answer, x cannot equal negative 5, because if you plug in negative 5 plus 5 is 0, and you cannot divide by 0. The other number that we would need to avoid is negative 3. If you plug in a negative 3 here, negative 3 plus 3 is 0, and you cannot divide by 0. So whatever I get for my final answers, as long as it's not a negative 5 or a negative 3, then we can accept those answers. All right, so let's take a look here at our common denominator. I've got x plus 5s, I've got x plus 3s, so every denominator needs to have an x plus 3 and an x plus 5. So on the left-hand side, I've got an x plus 5 here, so I am going to multiply times x plus 3. The middle equation, the middle fraction, has both, so we're good to go there. And then the last fraction over here has an x plus 3. We just need to multiply by x plus 5. All right, so let's bring this down. Let's see what we got. So on the left, I've got 2x times x is 2x squared, and 2x times 3 is 6x, over x plus 3 times x plus 5. In the middle, I didn't change anything. And I've got that x plus 3 times x plus 5 on the bottom. And on the right-hand side, I've got 3 times x is 3x. And I've got 3 times 5 is 15. On the bottom, I've got x plus 3 times x plus 5. Okay, now I'm going to go ahead and take care of this subtraction. I'm going to combine like terms here. I've got 2x squared minus 1x squared would be 1x squared. 2 minus 1 is 1. And then if I look at the x's, I've got 6x minus negative 1x. So 6 minus negative 1 would actually be a positive 7x. And then I've got this minus negative 10. Well, if you subtract negative 10, that would be like adding 10. So we combine like terms here. We subtract these two fractions. We still have our common denominator, x plus 3 times x plus 5 on the bottom. And of course, on the right-hand side, at this point, we haven't changed anything. We've got 3x plus 15 on top, and then our common denominator on the bottom. At this point, we see that those denominators are the same, and we know that if the bottom is the same, then the tops have to be equal too. So we are just going to use this equation across the top. X squared plus 7x plus 10 equals 3x plus 15. We're going to solve for x. Now this is another quadratic equation. With quadratic equations, we want to set it equal to 0. So I'm going to take this positive 3x, I'm going to move it over here with the other x's, and I'm going to take this plus 15 and I'm going to subtract it and move it to the other side. So that's going to give me x squared plus 4x minus 5 equals 0. You can either try to factor this or you could even use the quadratic formula. I'm going to factor it because off the top of my head I know that I could do x times x to get x squared. I also know that I could do x plus 5 and x minus 1 because 5 minus 1 is 4 and 5 times negative 1 is negative 5. So with the zero product property, I'm going to set each of these factors equal to 0. So I will end up with my first solution is negative 5 and my second solution would be a positive 1. Now remember in the very first step, what did we say were the impossible values for x? We said it would be impossible for x to be negative 5. So this first solution is what we call extraneous. It's an extra answer that doesn't actually work when you plug it back in. Because we know that if we were to plug in negative 5, we would see negative 5 plus 5 is 0, and you can't divide by 0. So that one doesn't work, but the other one is just fine. So we only have one solution to this equation, and that would be a positive 1.